它没有特别解释，就是以前还有VMware Business
Before, yeah, it was working with Oracle and SQL Server, Postgres, and Linux and Windows. And now they got rid of everything. It's only Linux and only Postgres. That's how I got the job.
How you come to Taiwan?
I like Taiwan, and they have an office in Taipei.
It's a choice. It's a choice.
Yeah. My manager wanted me to go to California, and I said no, I want to go to Taipei.
Oh.
Yeah, yeah. The life here is good. It's very convenient, and I like it too.
Those are reasons to stay here. Call me YC or cool.好，那我们这一场是国外来的讲者，是这 Julian。那我先讲，就是一个是贴纸，还有刚刚我不知道，然后那个刚刚有新的赞助品来，是资策会赞助的，所以那个东西可以吃。那如果可以的话，就是帮他们消耗一下那个 DM， 把它带走，这样子。对，好，那这一场这个应该是那个就是跟资料匿名化有关的啦。那我们时间就交给他。
Hi everyone, Zawan. I will do my presentation in English, unsurprisingly. So today I will talk about PG Anonymize, which is a new extension I've been working on recently. And the goal of this extension is to do like data anonymization for Postgres. So let me introduce myself quickly. My name is Julien in French, but Julian is easier to pronounce, so feel free to use that. I've been working with Postgres since 8.3, I think, in 2008. And I've been only using Postgres since because it's a great database. I've been working as a developer, Postgres developer and DBA over the years, so now I'm a Postgres developer. I wrote some other tools for Postgres. So HypoPG is an extension to do hypothetical or virtual indexes on Postgres. POA, it's a tool to do like a performance monitoring on Postgres, and some other tools. So for today's agenda, first I will quickly introduce PG Anonymize to explain what's its exact scope and goals. Then I will give some explanation on how it works under the hood with a lot of implementation detail both on the Postgres side and on the extension side. So if you're interested in hacking into Postgres or creating your own extension, hopefully it can help you to get ahead and do that. And finally, I will give some usage on how to effectively do data anonymization with this extension. So PG Anonymize. So the name of the talk is a new extension, but it's explicitly it's a module, not an extension. We tend to use the same word for both, but just to be clear what's the difference, the module is some compiled code into a shared library that you load into the Postgres server to execute like some random code you want. The extension part is only when you create extension, and that brings up a lot of objects on your database, like a new table, new row function, or anything. But for this extension, we don't need to store anything on the database, or at least not store anything in new object, because Postgres has a way to store what we need to do the anonymization. Also, some clarification on what exactly is anonymization. So one definition I found is to remove or modify personally identifiable information, or PII. That's something very popular recently with GDPR and a lot of new regulation. But obviously, you can use that for other purpose. Like if you want to, I don't know, hide the salary to do some stuff, it would work the exact same way. So it's not, it doesn't have to be only for PII. And also the resulting of this anonymization. So for PII, it means you can't use what's left of the information to identify one specific individual anymore. But hopefully you can still use the information in some way, because you can return null for everything, and then everything is anonymized, but you can't do anything of it. So for instance, if you don't want to do some statistics based on the age of some people, one way to anonymize the data is to truncate the birthday to like the month, the year, the decade, and then you can still know like if the people is like between 13 or 40 years old, something like that, and yet you can't use the birthday to identify the person. So for PG Anonymize, so the scope of the extension is to provide some infrastructure to let you define how you want to anonymize the data. So say like I want to anonymize the birthday with a truncation or something like that. And it does anonymization for you, but it doesn't do anything more, which means if you need a way to know like how to generate a fake name, fake address, or something like that, it's up to you. But it's usually not really a problem because there are a lot of tools and libraries to do that. One example is the Python Faker library. So you can find it on PyPy. And since you can use PL-Python stored function with Postgres, you can simply import that library and return whatever you need. And it's done in literally like 5 lines of code in Python. So it's very easy to do. So the goal of the extension is to be robust, safe, and transparent. Robust and safe is because once you properly configure the extension, the users shouldn't have any way to escape the anonymization. And also it's transparent because the user who connects doesn't have anything to do to be anonymized, and they have no choice, and they don't even know they're getting fake data. And it's also work with anything you want, so dynamic SQL, pgdump, any driver, any client, PSQL, your application, it will work the same without any limitation except one. You can't modify the data if they are anonymized because obviously you don't want to modify data you can't even read because you would just ruin them. So now let's see how it works under the hood. So the general idea of the extension is to intercept the query as they are being executed on the backend side and rewrite them transparently. So for instance, if you do like a select star from person, the extension, what it will do internally, will rewrite to this kind of query, which will be like a select star from, and instead of the table, it will replace it with a subquery that does the anonymization. So in all the slides, what I use is return a hard-coded string for a phone number. And it's anonymized because we only get like the phone code, so you know where the person is from, but not the real phone number. So if you use this one instead of this one, it returns the exact same set of rows and columns, but you will only see the anonymized data. So in order to do that, we use what's called the hooks in Postgres. So Postgres allows any module to inject some custom code at different points in the query workflow or other part of Postgres using those hooks. So when the module is loaded, it simply need to declare the list of hooks you want to use. And when you do something on Postgres, so in this case, when you execute a query, the hook will eventually be called. And at that point, your custom code is executed, and it can do whatever you want it to do. So the only way to do this rewrite is find a hook that allows us to do that. So let's focus on the query workflow. So, here, this part is on the client side, and everything else happens on the back end. So when the client sends a random query string, so here select star from an anonymized table, the first step is the parser. So it takes like text, and it returns one or multiple raw query objects. So you can feed multiple statements at the same time in the single query string. So we'll get one query per statement. Then for each of these raw query objects, there is a parse analysis stage, which is done once per raw query. And it will return a query object. Then if that query uses any relation that uses rules, so it can be either a view or an explicit rule, it will return, go through the rewriter and return one or more query. So you can think, for instance, if you declare a rule that does do also, two query will be actually returned and both will be executed. So that's how you can get from one simple query to having multiple query executed by Postgres. Then for each of the queries, the planner is called, and the planner will return one plan for each query. So we can focus on the parse analysis step. So the parse analysis transforms a raw query into a query object. And this query object contains all the information that the planner will eventually need to do its work. So for instance, if you do like a select star, what it will do is expand the star into the list of each column in the table and other stuff. One extra step the parse analysis is doing before returning is calling a specific hook, which is called the post-parse analyze hook. And we can use this one to do the anonymization because it's early enough in the query processing stage to do the transformation we need. So if you're interested in how it works on the Postgres side, the hook is defined in alias.c file. So I have multiple ways to call the parse analysis depending on the parameters. So one of the top level entry is parse analyze fixed params. So it uses the parse tree. It calls a transform top level statement. So that's parse analysis stage. It returns a query. And then it checks if a hook is declared. And if the hook is declared, just call the hook with a query and two other objects. So the parse state and the jumble state, which is extra context for the query. So your hook can do anything it wants with the query, and it will return as is. So obviously, you can do like very bad things. You can corrupt your data and crash Postgres, so you have to be careful. But it's also very powerful, and you can do something like a PG anonymize. So let's focus on a query. So it's on the code side, it's a C structure, and it contains all the information you need for the planning stage. So you get like the list of fields, the where and the join clauses, and also you get the list of tables, which is stored in a field called Airtable, which stands for range table entries. And it's a list, it's a Postgres specific structure, and it's been changed recently, and now it's mostly like a simple array. So let's see the range table entry. So it's another C structure, and it's used to describe any kind of relation. So a relation is literally anything that returns rows. So it can be a plain relation, it can be a subquery, it can also be a join, because once you join two tables, it returns a new relation that gives a new set of rows. So here I show the RTE can, which is the two can I'm interested in the extension. And the range table entry itself, so it stores a lot of fields. So you have the definition is parsenodes.h. So one thing, it stores the RTE can, so which kind of relation. And then depending on the can, you have different fields that are valued or not, depending on it. So for a plain relation, you get its OID and its role kind. And for a subquery, the only thing that's stored is another query that contains what will be executed. So it's a nested query. So the interesting part here is that whether it's a plain table or a subquery, it's the exact same object that's being used. Also internally, the range table entry and the query object doesn't refer to object as name. So if you do like select ID from table, you don't store ID, the string ID and the table name. What you store is a number. So for the columns, you store like which the attribute number, so like the first column, the second column, and so on. And for a table, you don't store its name, but you store its offset in the list of range table entries. So what it means, if we hack the range table entry to change it from a query, a relation RT to a subquery, it will work the same, because if you select an anonymous field, it will refer to the first column on the second table in the range table entries. It will work the same, so nothing is broken. So all we need to do is change this RTE to use the subquery instead. So how is it done in PG Anonymize? The first step is to generate the anonymized query that return all the fields anonymized or not. So to do that, we iterate over all the relation attributes. We're trying to find if there is a security label. So I will give more explanation on that in the third part, but that's how you define the anonymization rules. And also do some extra care. For instance, if you have inherited or partition table, you inherit whatever anonymization rules from the upper table. So you don't have, if you have 1,000 partition, you don't have to specify the same rule 1,000 times. So just easier. And so that's how it's done in PG Anonymize. So you get a first function called so PGAN is for PG Anonymize. Get relation suc labels, so it gets all the security labels in an array. Then it loops over all the attributes. And then if you find a security label for this column, it appends like the expression, and it aliases it as a column name. The alias is actually not required, because what we need is a column number, not a column name. But if there is any problem later on, like for instance your anonymization rule is broken or something, you get something more readable. So it's nice to have. And if you don't have a security label, we just put the original attribute name, and we do like a simple select from, and that's it. Once we exit this part, we get like the string, the query string we want to use as a subquery. And then using that, we do exactly the same as Postgres would be doing for a normal query, which is we call the parser, and we get a raw parse tree. Then we do the parse analysis again to get a query. And in case of PG Anonymize, we stop here because we know we don't want to expand any rule. And then, since we have the query that we can use as the RTE subquery, we replace it in the original relation RTE. So that's how it's done in PG Anonymize. So it's a pseudocode because there's different code that's used to get the exact thing. But let's assume you have the range table entry and the SQL query text. You call PG parse query. That's the main entry point for the parser in Postgres with a SQL string. We get a list of row statements. Since we generated the query, we know there is one and only one statement generated. So we get the initial one as a row statement. We call again the parse analysis. We get a subquery, and then we just hack the RT in place. We change its RT kind. We set the subquery with the subquery just generated. Some other stuff to make sure the RT is the correct state, and that's it. We can just we're finished. We continue, and now Postgres will return anonymized data instead of the original data. So as I mentioned, it works because everything is referred by attribute column and position in RTE and not a specific name or something. So it works well for a DML query, like any select statement. If you do utility command, so for instance, copy command that's done by explicit copy or pg dump, it's a bit different because it doesn't go through the same schema I showed before. It's directly executed. But hopefully there is another hook for that. So it's called the process utility hook. So any utility command goes there. So in case of PG anonymize, there's two kinds of statements we want to change, which is copy column name to std out or somewhere, or copy and a query. So in both cases, we do the exact same transformation, and we generate the exact same command, which is copy, and the anonymized query string that was generated. So it's internally use the exact same code in a different hook. So now let's see how it's you can use PG anonymize to effectively anonymize your data. So as I mentioned earlier, it's using a declarative approach using a security label. So the security label is a utility command specific to Postgres that's used to store like plain string and affect them to any kind of object. So in order to declare a security label, you need a security provider, which is done by PG anonymize once it's loaded. So the first step you need to do is make sure PG anonymize is loaded. So usually you don't want to load it for everyone because it will add some overhead you don't want if your user is not anonymized. So just do it for the role that will later be anonymized and for the one you use to declare the security label. So when it's loaded, you declare one anonymization rule for each column you want to anonymize, each column of each tables. Then you use a security label for each role you want to see anonymized data. And then you want to make sure that PG anonymize is loaded for all those roles. And once it's done, it's ready to anonymize data. So to load PG anonymize, you can simply use a load, which is another utility statement. You need to be super user for that. But if this is a problem, you can find give non-super user a way to do it if needed. But usually you don't want a non-privileged user to declare anonymization rule because it's security sensitive. Then you declare the anonymization rules. So the syntax of security label is security label for the security provider. So for PG anonymize, it's PG anonymize. You can have multiple security provider loaded at the same time. For instance, there is SC PGSQL, which also relies on security label and can have both loaded at the same time and they work together without any problem. Then you use on and a kind of object you want to store it on. So here it's on a column. Then you specify which column you want to use and you use is and you put a simple string to describe how you want to anonymize your data. So here that's how you have to be creative to do the anonymization part. It's a good idea to use dollar quoting. So you use $$ or $something$ instead of a simple quote. It works the same, but if you do that, you can then use a simple quote inside your expression without having to escape or double quote them. So here, the expression itself is like simple quote plus 886 and everything. And that's a naive way to anonymize a phone number. You also have to make sure you return the correct data type. So here I use semicolon text to explicitly cast it as a text. If you don't use the correct data type, PG anonymize will return an error because it checks it. Then you do exactly the same, but for the role, and the rule, like the label you store, it just anonymize. And then you modify session preload libraries for the user. So here it's for the Alice user. So you also modify the session preload libraries for this user to load this extension. So it's alter role Alice, set session preload libraries, and you set it to PG anonymized, and you can have a multiple column separated list of modules you want to automatically load. So be careful, this is only applied at the connection start. So if Alice is already connected somewhere, this connection will not have PG anonymized loaded and will continue to see the original data. But you can do like a select PG terminate backend and close all existing connections. And once it's done, so here as an example, if I connect using PSQL and the user Postgres, and I do like select star from public.person, I see the original data. And if I connect as an Alice user, now I see the anonymized data. So it will work exactly the same way with any client, any driver. It will work with dynamic SQL, pgdump, and anything you want to use. There's really no restrictions. So what is already handled, so it's a work in progress. The extension is not finished yet, but soon to be finished. What's already done is, as I mentioned, the inheritance of the rules. If you have a partition table or inherited table, you will inherit what's declared on the upper partitions. So you don't need to specify them like 1,000 times. And a lot of sanity checks. So it checks that it returns the correct data type, otherwise it returns an error. It also checks that the anonymization rule doesn't have any SQL injection. It's easy to do because since we use the Postgres parser, we just have to check how many row query are returned. If it's more than one, we know there was, for some reason, the rule returned 2 queries, and then it's an injection. So also it will return an error there. And also it checks that the anonymization rule itself doesn't try to write any data. So the next step that should be done, so it's already work in progress. It's not finished yet, but soon. So a lot more sanity checks. Do the exact same sanity checks I mentioned here, but those are already done at the definition time. So we want to do that at runtime because you can still alter a column data type, and then we want to make sure that the new data type is the same as the anonymization rule. And also correctly handle rules because those are handled a bit differently than a simple query. If you remember, it's done at after the post-parse analyze stage. So we just have to find another hook to also anonymize those. Okay. So that's all for today. So if you're interested in the extension, you can find it on GitHub. And if you have any question, I will be happy to answer. Thank you.
What is your motivation to create this extension?
Oh, it's because I'm from Europe. And in Europe, it's
GDPR.
Yeah. GDPR is very, very hot topic right now. Like every company has to comply with it, and a lot of customers are asking for a way to anonymize data because they need it for regulation. There is similar regulation in the US. I work from an American company, and they have the same kind of problem. So there are other extensions that try to do anonymization, but they have some limitations. So I wanted to have like a simple tool that does just anonymization, but does it well. So that's why I created this extension.
Okay, and Julian, your approach is very clever. So, but I'm not quite understand the difference between extension and module.
So, for instance, do you know auto-explain? So auto-explain is also only a module because once it's loaded, it does its work, which is like automatically does output an explain plan at the end of the query execution. But you don't need to do anything on the SQL side. You don't need to do like alter table, set auto-explain enable or something. You just need the code to run. So that's the module part. The extension is to bring new object. For instance, if do you know pgstat statements? Yeah. So pgstat statements, you have a module because it's gather statistics, accumulated metrics on query runtime, number of execution, and everything. So it's done automatically by the module. And you need a SQL object to access those data which are in shared memory. So that's why the extension is for. It's,
if I want to use the Analyze, I need to compile before. I need to compile with my Postgres.
Yeah. Oh, but usually it will end up in a PG apt or PG yum. So you can just do like a apt install PG anonymize or yum dnf install PG anonymize, and you get the binary. There is like a whole network of extension, and you can find it on the PGDG repository. So they are already compiled for you.
And I have more. What is the pro and con between extension and module?
It's just answer like different parts, different problems. For instance, if you need a new data type, you need it to be accessible on the SQL level. So you need an extension for that. If you just need to have like code running in the backend, like PG Anonymize, you need a module, but that's not something you choose because you think it's better. It's because that's the way to implement it has to be an extension on a module or both. So it really depends on what you need to do. If you need like custom C code, it's a module. If you need something at the SQL level, it's an extension.
I have a problem. When I use this, I query anonymize the data, where it uses indices on a table.
What will happen if you have an index on anonymized data? It won't use, like you can't use the index to see the original data because since it replaces the query you're using, you're not doing select star from anonymized table, you say select star from select something. So even if you do like where anonymized data is 1, the 1 will refer to the anonymized column. So Postgres don't even try to use the index for that because it's a plain expression and not an original field. So it won't use an index because it doesn't see the data, but it also won't see the original data. Sorry?
It's possible I create an expression index
Mm-hmm.
for anonymized.
Oh yeah. You can create an expression index, but you have to make sure it's synchronized with what's actually the anonymization rule. That also brings another point. It's like when you use this extension, it's way slower than accessing the original data, because here, if you do like select one column from table, it will still return all the columns. So it will. It may be possible to try to know which column you try to use, but it will be a lot of code and it will be more fragile. So the point of the extension is to be safe and robust, not to be super fast, because I don't think anyone wants to do like OLTP workload on anonymized data. So it's slow. It can be optimized, but the first rule is to be robust and correct, not performance-wise.
哦，那我们这一场就到这边结束了，再次谢谢大家。OK，thank you。